Let's get started. Hello, everyone. My name is Lucía, and I'm a data scientist here at CARTO. And today I'm very, very excited to present you the new CARTO Spatial Features version. This is actually the third version of the dataset that we've released so far. And now it comes with more very interesting features, including a human activity index that is a proxy of human presence. And we're actually very, very thrilled to show this to you. So in today's LinkedIn session, I'll first be going through what is spatial features in general, for those of you who are not familiar with it. And then I'll jump in to update you on what's new in this version 3. And then we'll see like some general use cases so that you get to know how you can leverage this dataset for your own projects and your specific like use cases. So to begin with, what is the spatial features? The key of spatial features is that it is a global dataset. So that means that we provide information, actually location-based information for every country in the world. So basically this dataset provides access to the most commonly used geospatial data. And what it does is the good thing about this is that this facilitates a lot spatial modeling at scale. These types of data include sociodemographics, points of interest, human activity, and many other variables that we will explore later in the session. Another important thing about this data is that it is open source. It is built upon open source data. What we've done is we've curated and combined data from all these different sources that come in many different formats into a common, unified, and consistent geographical context. What this does is this helps manipulating the data for spatial analysis and spatial modeling, basically. This way, users do not need to gather, cleanse, and prepare the data, so that this drastically reduces the amount of time that they tend to spend on this type of tasks, which is actually very, very time consuming. So having all this data already processed in a unique format and readily available, it's very useful because it reduces processing time a lot. It makes data scientists and data analysts lives much more easier, basically. So now that we are more familiar with spatial features, I just wanted to quickly give you like the basics of the data product that we are offering. So first, regarding coverage, as I've just mentioned, the data is available globally, so we can provide either a global dataset or a country-specific dataset if you're just interested in a specific country. A good thing about spatial features is that for those of you who are interested in the US, in Spain, and Great Britain, we have this data publicly available for specific resolutions that we will see in a second what this means. So if you're running an analysis in these regions, that is something interesting for you to know, I think. So about the geographic support, this commonly geographic framework that I was referring to in the previous slide, basically data is available in two different geographic support systems here. We have Quadbin and H3 spatial indexes. Basically, for those of you who don't know what spatial indexes are, they're just a way to gridify the space into cells that are kind of like connected between each other so that running spatial computations is much, much faster. So instead of relying on complex traditional geographies, we are working with spatial indexes that makes our lives much easier, basically. And going back to spatial features, we are supporting 3 different spatial aggregations, which are Quadbin 18, Quadbin 15, and H3 resolution 8. Now, regarding the variables that we have, as I've just mentioned, we are combining data from multiple sources. So we have demographics data coming from WorldPop. In this case, we have like total population. Then we have also population split by gender and also by age gap. So that if you're just want to focus on a specific population segment, you just have the data directly available in spatial features. For example, you want, I don't know, female population between 15 and 45, then you have it. We also have points of interest data that comes from OpenStreetMaps. Basically, what we are doing here is to count the amount of POIs of specific categories that we have for each of the cells. We have different categories. For example, we have retail POIs, we have transportation POIs, tourism POIs, food and drink POIs, and a few more categories that are very, very interesting for many different projects. We also have climatology data coming from WorldClim, that is temperature, precipitation, solar radiation and things like that. We have elevation data, which is also very interesting. And we have urbanity, which is actually a variable that CARTO has derived. We created a model to estimate or to predict like the urbanity of different areas based on specific variables. And this is also available in Spatial Features. And then we have more variables, but we will discuss them in a second because these are like new variables that come in this version 3 that we are just releasing. So let me first share with you how this data looks like. So for example, we have here population, we have here also, I think it's average temperature. This is the urbanity data that I've just explained, elevation, and amount of POIs for specific categories, as you've seen. So what's new in version 3? As you can see in this slide, the new version includes three new variables, which are nighttime lights, cell tower counts, and also human activity index. The rationale or the aim of releasing this new version was that we were getting a lot of requests about human mobility data. There's a lot of people that is interested in this kind of data, and it's not so easy to find a data set online that provides this data. So we did a lot of research and tried to come up with an index that represents like a proxy of human activity or human mobility for our users to use in their projects, and that would be like available globally. So that's why we decided to do this research and come up with this new data that we think it's very, very interesting for many users and many use cases. So as you can see, regarding nighttime light data and cell tower data, these have also many different applications. For example, the nighttime light data is an indicator of multiple factors. For example, it's an indicator of population, of infrastructure presence, of places where there's a lot of energy consumption. So this can be used in many different analyses. And also on the other hand, we have the cell tower data, which is also a very interesting indicator, not only of telecommunication infrastructure, but also it can be used as a proxy of human presence, as you will see later, because this is actually a bit of spoiler. These two variables, we've used them to create this human activity index that I'll explain in a second. But before, I wanted to show you how the nighttime light data looks like. So this is a map showing the nighttime lights worldwide. I think this was in New York, yeah. But if we zoom out, you can see how this data looks globally. Of course, there's more lights in those big cities, but also in like factories that may be located in remote areas. So you can see this. We will share the links of the maps with you so that you can play with the data and take a look at the map by yourselves. So now, moving forward, let's talk about the most exciting part, which is this human activity index. As I've just mentioned, this is an index that has been modeled by CARTO. It is actually a composite score. So what we've done here is we've taken different variables and we've combined them into a meaningful indicator that is a proxy of human presence. And this indicator is a score that goes from 0 to 100. So that 0 represents locations with very low activity and 100 represents highly busy areas. One important thing to mention here is that this index has been derived at the country level so that we can compare locations within a country, so that we know that areas, that locations with higher scores are more busy areas and are areas with a larger floating population. So this is how we build the index, but you may be wondering which variables we used to actually derive this human activity index. So we can see that in the next slide. As you can see, what we did was to do a lot of research and come up with variables that are actually indicators of human presence. So for example, we have the population, which represents where people live. So where people live, it's places where there's people moving around. Then we have also the points of interest, that represent like infrastructure presence, which again represents locations where there's a lot of activity because people go to points of interest to have lunch, to shop. So this is also a good indicator. And we've also considered telecom cell towers and nighttime lights, again, because they represent where people live and where people work. So we've combined all these variables into one to create this human activity index. But an important thing to mention here is that you have these 4 variables available in the spatial features dataset. So if you want to combine them, giving specific importance to some of them, you can do that, and you can derive your own human activity index as well if you prefer to do so. So that's also a very good thing if you're interested in this kind of analysis. So this is how the human activity index looks like in a map. We're showing here how it looks in the US, and as you can see, it has larger values in like big cities like New York. We have also San Francisco and LA on the other side. So this is a very cool map that again, we will share the link with you so that you can take a closer look at it. So if I go to the next slide, we can jump into how can we use this data. We will see some real use cases that may be interesting for you so that you can get to know how you can work with this data in specific projects. So for example, imagine that you are a retailer that I don't know, wants to open a new specialty coffee shop and wants to quantify the impact of the new shop openings on existing ones. So then what you would do would be to run a cannibalization analysis to see if you are capturing like the same floating population in these new stores, or the same I don't know, young adult population, let's say between 25 and 45 years old. So that you would know if you are like overlapping population between your existing stores and the new stores that you want to open. Also, another thing that you could do would be to see whether your new store would be located in an area where there is already a lot of food and drink POIs, a lot of competitors, so that you would try to understand the impact of this on your business. Is this good? Is this bad? You can run this type of analysis using this spatial features data to get insights of this type. Another use case that you could focus or that you could encounter would be to use spatial features to understand what is the population or the floating population, that would be using the human activity index, that is covered by the signal of your telco network. For example, you may want to know, I don't know, how many people older than 65 years old is covered by a signal of intensity, whatever, so that you can measure like the quality of your service for this specific like segment of the population. That would be another interesting use case. And lastly, another example would be using spatial features to build composite scores. Building composite scores using spatial features is very direct and very easy because you have all the variables already processed, so you just need to combine them. And also in CARTO, we provide the tools to build composite scores, so it's very, very simple. We wanted to showcase an example in which we derive a composite score using elevation, human activity, and precipitation data to understand the risk that is associated with like insuring properties in different locations. We want to know what's the demographic or the economic impact of flooding risk in different areas, and we are just combining all this information to create our risk index and try to get some insights from it. So if I go to the next slide, we can start seeing spatial features in action. So what we are going to do is I've prepared a very simple workflow so that we can create this flooding risk index in New Orleans to get some insights only using spatial features. So if I go to the workflow that I have here, you can see how the workflow looks like. So basically here we're just selecting the variables that we want to use, which are the ones that I've said before: human activity, elevation, and precipitation. We are combining them, creating a composite score, and then we are just analyzing a bit what we get. Actually, what we are doing here is basically trying to understand if the risk of flooding is larger in urban areas or if it is larger in rural areas. So we're just, as you can see here, like getting like the average score of its urbanity level so that we can get some insights from it. But we're using here urbanity, but we could be comparing with any other variables of interest that we would like. For example, I don't know, is the risk larger in locations where there's more young people, or is it larger in locations where there's elderly people? So there's a lot of things that you can do here using spatial features. We've created also a map so that you can see the resulting index. it's very easy to do this from workflows. You can just go here to map and then select create map, but I have one already prepared for you and styled so that it's easier to follow. So you can see here on the left, the fluid risk index that we've created. And as you can see, the risk is larger in this area here, which is actually the city center, but also here, which is very interesting because this is an area, as you can see here from the variables that we've used, that has a very low elevation. This is at the sea level, and also it's an area where there's a lot of precipitation. So that makes sense that the index is larger in here. And we've also included here the urbanity layer so that we can get insights from it. And as you can see, urban areas, which are these like yellow or orange ones, have a larger, a higher risk than other areas that you can see here. So that's all on this session. We've included here some relevant links that we think may be useful for you. Please make sure you check the CARTO Spatial Data Catalog to take a look at the features and the different variables that are available in this data set. And of course, you have also the links here to the different blog posts that we've published with the releases of each of the features. If you're more of the data sets, if you are more interested in understanding what are the data that is present there, what are the data sources, and of course, do not hesitate to contact any of us if you're interested in trying this data. I hope you enjoyed the presentation, and also I hope that you're as excited as we are about this new release of Spatial Features. So thank you so much for joining today, and I hope to see you in the next LinkedIn session as well.